Hello, are you able to hear me? Hello?
Yes, sir.
Yeah, I'm so sorry
Yes,
about
sir.
it. I don't know. For some reason, the system crashed. Okay, all right. So I was talking about the problems, right? Ah, there we are. Right. Okay. So you're able to see the screen, right?
Yes, sir.
Okay, fine. So now look at some problems based on RL and RC circuits. Okay, so you can take down this problem. Problem number 1. Okay, the problem description is being given. Okay, I'll quit the slideshow mode because I have to type something on the screen. That's the reason I'm quitting the slideshow screen. Okay. Hope you understand. All right. So it says a 200 volt, 50 hertz inductive circuit takes a current of 10 ampere, lagging 30 degrees. Okay. Find the resistance of the circuit, reactance of the circuit, and inductance of the coil. Okay. So this is the problem statement. Okay. So if you look at the given data, so you have been given with the voltage, which is 200 volts. And also you have been given with current, 10 amperes. And the phase angle, 30 degrees. Okay. So in the solution, V is equal to 200 volt, which is given. I is equal to 10 amperes. Okay. And phi, I cannot write the symbol phi, hence I'll just use Fi. Okay, so Fi represents the phase angle. So phi is given as 30 degrees. Okay. So since voltage is given and current is given, what you can find is the impedance that is over here. Z is equal to V by I. See, you can apply Ohm's law to even AC circuits, but in AC circuits, we consider the RMS values of voltage and current. So Z is simply 200 upon 10, that is 20 ohm. So impedance of this particular circuit is 20 ohm. Okay, that is just the impedance, but we do not know the constituents of impedance. So constituents of impedance, okay, if you can recall the yesterday's lesson, for RL circuit, it is R plus J into XL. J into XL. Okay. So impedance is known. That is 20 ohm. Now you need to find the parameters of the impedance, that is resistance and reactance. Okay. How do you find the resistance and reactance? So whenever a problem of this kind is given, you need to look at this important data, that is the phase angle. So what you can do is you can quickly draw this impedance triangle for RL circuit because they have told inductance of the circuit. So x coordinate is R and y axis parameter is XL and the resultant is Z. And you can apply the trigonometry, that is, you can even take cos phi as adjacent by hypotenuse, or you can even write sin phi as opposite by hypotenuse, or rather you can take tan phi as opposite by adjacent. Okay, so any formula you can take. Now if I were to take, say, cos phi is equal to R by Z from this right angle triangle, what I can do is I can simply cross multiply. Okay, and I can get R is equal to Z cos phi. Correct. I have just cross multiplied. So I'm going to get R is equal to Z into cos phi. So R is equal to Z. We have already found the value of Z, that is 20 ohms, into cos phi. So that is cos of 30 decrease. Okay. So how much you'll get RS? Can anyone tell me? And just put it in your
10
calculator.
root
10 root 3.
Again, 10 root 3 kg of sugar I cannot purchase, no? So you have to always tell me.
17.3.
Right. 17 point something. Yeah.
32.
Okay. $17.32 ohms. Perfect. So once you are done with the calculation of R, you can find XL. There are various ways to determine XL. Okay, you know Z is equal to under root R square plus XL square. So XL is equal to under root Z square minus R square, or you can use this formula. XL is equal to Z into sine phi. Okay. You may have multiple approaches, but always you will get a unique solution. So how much you'll get? 20 into sine 30 is half, right? So 10. 10, correct?
10.
10 ohm. But there's a problem, right? Z is equal to R plus JXL. If I add up R and LXL, how much do I get? How much will I get? 17 plus 32 plus 10, 27.32, no? But I was supposed to get 20 ohm, right? What went wrong? Or am I saying something wrong? Are you getting the point? I said Z is equal to R plus JXL. So if I do the algebraic sum, that is R, that is 17.32 plus 10, I will end up in getting 27.32. But initially I had calculated Z is equal to 20 ohm. So what is the mistake I'm doing?
Square root.
Right. So it is not your resistive circuit. In case of resistive circuit, you know, you could add the voltages or currents straightforwardly, right? Whereas in case of AC circuits, you cannot just take the algebraic sum. You need to take out the vector sum. So your Z is equal to under root R square plus XL square. So it is under root 17.32 square plus 10 square. So if you take out Z is equal to SQRT R cap 2 plus XL cap 2. Okay, tell me how much you'll get. You'll get close to 20 ohm. So always remember, in AC circuit, apply Pythagoras theorem and take out the resultant value. Don't take out the resultant value simply by taking x plus y, which is incorrect. Okay. All right. So you have found the resistance and you have also found the inductance. And finally, you can calculate, reactance you have found. Finally, you can calculate the inductance of the coil. So XL is equal to 2 into pi into F into L. Okay. So that implies L is equal to XL divided by 2 into pi into F. Okay. So how much you'll get? $31.85 millihenry.
0.0318.
Yeah, or
Yes, sir.
31.847 millihenry. Okay, are you getting this?
Yes, sir.
Yeah, all right. So
Yes, sir.
done. So that's all. So this
Yes.
is about problem 1. R, the first part, XL, the second part, and the inductance, the third part. Okay. So this is how we solve AC circuit problems. All right. So this is the simplest problem. Okay. Now let's try solving problem number 2. Okay. Quickly, you can go through with the problem and you can make an attempt to solve. First, write down the given data. Okay. So it says V is equal to 230 and is applied to a series connected resistor and inductor, right? So it's a RL circuit with R is equal to 30 ohm and L is equal to 0.5 millihenry. It's not then. Okay, fine. So this is the data. So you are supposed to find firstly XL. Okay. How do you find XL? 2 pi FL. 2 into pi into frequency into inductance. This is what I'm doing. XL I'm finding out. So XL I'm finding out. How much you'll get? 0.157?
157.
Yes, sir.
157, huh?
157 milli.
157.
0.157.
Millihenry.
Yeah, it's millihenry, no? I think you missed out the multiplier.
Yes, sir.
0.157. Is it correct?
Yes, sir.
Yes, sir.
Sir,
0.157.
0.157.
Correct.
Ohm.
Done. Okay. Next, you find out the second part. Current through the circuit. Okay. This part. Current through the circuit. How will you find current through the circuit? Ohm's law. So to find I, apply Ohm's law. Apply Ohm's law. Okay. So that is V is equal to I into Z. Okay. Since you need to find current, so I is equal to voltage by impedance, right? So I is equal to voltage is 230 divided by impedance. What is the impedance? So impedance is square root of R square plus XL square. That is equal to, can anyone tell me? R square is 30 square.
30.
Yeah, and 0.157 square under root. It's about 30 only, right? So
Yes.
230 by,
30, sir.
yeah, it's
Yes,
30.
sir.
So 230 by 30 is
7.6.
7.6.
yeah, 7.667 amperes. That's part 2. Okay. Next is voltage across each component. Okay, voltage across each component. So RL circuit, what are the different voltage drops you will find in RL circuit? Resistive drop
Across
VR, correct, and inductive drop VL. So resistive drop, we'll find it as I into
R.
R, correct, and inductive drop going to be I into XL. Okay. So you can find out the respective drops. 230. Correct?
Yes, sir.
And
1.2.
1.2 volts. So that means to say the
That-
circuit
That is
is
22.9, 22.9.8, sir.
which one? VL.
VR.
VR.
No,
Okay.
it's correct.
7.667.
2 to 9.8.
Two-
It's not, we are not getting exact 230.
Okay, 229. It's
7.67
okay.
into
It's okay.
30.
It's okay. No problem. Because I took pi as 3.14. That will give. Okay, how much you are getting? 229 point some change, right? It's very close.
229.8.
Yeah, 8. That's okay. Fair enough.
It's 230.01.
Yeah, I got 230.01. Doesn't matter. It's a difference of just
Yes, sir. 230.
0.02 volts. That's okay. No problem. And what about inductive drop? 0.15.
1.203.
Yeah. 1.2 volts. 1.2 volts. Right. So you can observe from this problem that your circuit is more of resistive circuit, right? Because your supply voltage was 230 volt and your resistance drop is also very close to 230 volt. You can clearly observe your inductive drop is just 1.2 volt. Okay. So voltage across each component is also found. Okay. And finally, the phasor diagram. Phasor diagram. Okay. So phasor diagram. Okay. How will you draw phasor diagram? You don't have to, fix the scale as such. A rough phasor diagram you can draw. Okay. So you can start doing it in your notebook. So first let me take current as the reference. I done. And then let me project the two voltages, the resistive voltage 229.9. Somewhere here I'll project resistive voltage. Let me give a different color, say red color with a different weight. Okay. So the red line indicates VR. Okay, done. And then you need to project VL. Okay. Now, while projecting VL, you have to apply your logic. See, 1.2 volt, when you compare with 230 volt, it's like drop in ocean. So 1.2 volt should be of very small value. That's it. That's it. So some different color, let me give. And probably a thicker line. Okay. So this is your VL. Okay, let me slightly extend this line. Okay, so this is VL. Okay, having very small vector length. Okay. And then the resultant. So resultant can be given by the closing side of the right angle triangle. Okay, this is the resultant, which is V. Okay, so V is equal to 230 volt. Okay, so in the vector diagram, you have to represent everything, different voltages, everything you have to represent. And VR, you found it as 229.8 volt. And VL was equal to 1.2 volt. And current was 7.667. Done. And this is the phase angle. Okay, finally you have to also show the phase angle. Okay. So angle phi. So I am writing phi because I don't have the provision to include phi symbol, but in your notebook you can use the symbol phi. Okay. So what's the phase angle? Can anyone tell me quickly?
0.29 degree.
0.29. Okay. How did you find
0.298.
Okay. Phi is equal to, probably you have found, cos inverse of R by Z, probably you have used, right? This formula you have used, no? Or XL by R is also fine. Tan inverse of XL by R is also fine. So 0.29.
29.
Okay, 29. Okay. If you see the phase angles, it's very, very small. So this angle is very, very small. You can say almost it is equal to 0 itself. So that's the reason, you know, you are getting the resistive voltage VR very close to the supply voltage. All right. So it's a typical problem which you can expect in your external as well as internal exam. Okay. All right. So that's problem 2. Okay. Problem 3. Okay, it's the same thing. This one you consider RC circuit. Okay, can you try RC? So given a capacitance value and a non-inductive resistance value, okay, and the supply voltage 100 volts and the frequency of supply. Okay, that's all. So firstly you need to determine the impedance, that is Z. Okay, so Z for RC circuit, because it is given as a capacitive circuit, so Z for an RC circuit is given as square root of R square plus XC square which is equal to and XC is equal to 1 by 2 into I into F into C.
40.05.
Okay, you're talking about Z, right?
Z is 44.7, sir.
Okay, okay. So 40.05 is XC.
C.
Okay, all right. And this is
44.7.
okay, 44.7 ohm. Okay, so that's the impedance, followed by So impedance is done. Let's calculate the current now. Okay. How will you find the current? Ohm's law. I is equal to V by Z. V is 100 divided by Z is 40 point.
2.23.
All right.
2.23.
2.23.
2.23.
2.23 amperes. Excellent. And the phase angle. Phase angle. Phi is equal to whatever. Tan inverse, sine inverse, anything you can take. Tan inverse of XC divided by R.
53.16.
50?
3.16.
53.16. Okay. Degree. Okay. Fourth one. Okay. Though it is not given, normally they will give in your external exam the vector diagram. Okay. Can you try drawing the vector diagram? Vector diagram. So RC circuit, I, first let us represent I. Okay, this one. Okay, I'll do it here. I.
So Z we are getting 50.04.
Z you are getting 50.04.
04.
Okay, 1 minute. It's, see, Z is 30 square plus XC square and the square root of answer. 50.04 you will get, no? Yeah. Okay,
Yes,
2.
sir.
Okay, let me just see. XC, let me first see. 2 into 5 into F into 40.05. Yeah, XC is correct. And Z, I don't know. How did you make that error? With a non-inductive resistance of 30. So R square is 30 square, right? Plus XC square, 40.05 square, and the square root of answer. 50.04 I'll get. Did you all check?
50.04.
Correct, no? 50.04. So obviously this also will change. Probably doubling will take place. Almost 2 amperes. 1.99 will get. Correct, right? And
Yes, sir.
yeah, XC will be the same. Yeah, XC is 53.16. So I, okay, is equal to 1.99 ampere. And VR And then VC. And then the resultant. So VC is equal to I into XE, and then V is equal to I into Z. Done. Okay. And there's a phase angle. Phase angle. Fine. Which is equal to 53.16. Okay. So I would request you to not to keep VR is equal to I into R. Okay, you'll have to find the value of VR and VL, and so as V. So V, you must get it as 100 volt because that's the supply voltage. Okay. So you please find out the values of VR and VC. All right. Okay. Okay, fine. Problem number 4. I'll leave it to you. You please tell me. I'll be waiting for the answers. Okay. I is equal to. Okay, and the second part is the power factor. Okay, what is power factor? Cos of phi. And then the phasor diagram. Phasor diagram. Okay. So try finding out. Try solving problem 4. You're able to hear me, right?
Yes, sir.
Yes, sir.
Okay.
The I is 7.49.
49. Yeah, 48949. Correct. What's the power factor? So power factor-
0.299.
Okay, power factor angle is 72.56, right? In and around. That's okay.
2.57.
Yeah, 57. Fair enough. And then the cosine value of the angle 0.2. Okay, 0.299.
0.29.
Okay. Yeah. So I want you to pay attention over here. This power factor is taken as lagging. You can just write lagging. Lagging. That's because in case of sorry. It's a capacitive circuit. No, leading. It is leading. Sorry.
Leading.
Leading. Okay. Simply because I
Voltage
leads
leads current.
V by
I.
angle phi.
90.
Angle phi. So whenever we find the power factor, it makes sense to include whether the power factor is lagging or leading in nature. All right. For a RC circuit, always you'll get a leading power factor because current starts first. And for a RL circuit, voltage starts first and current lags behind. Okay. And the phasor diagram. So probably, you can draw the phasor diagram as a homework and you can share it in the group. Meanwhile, I will send across a few more problems, as assignment, and you can submit the assignment in the Google Classroom. Okay. And tomorrow I will be discussing about problems related to series RLC circuit. All right. Any doubts?
No, sir.
Okay. If you don't have doubts, you can, quit. And let me just wait for 2 or 3 minutes. If in case, if any one of you have some doubts, I'll be able to clear it off. We'll meet tomorrow.
So the phasor diagram is the waveform diagram, sir.
No, phasor diagram is the vector diagram. Waveform is the graphical representation of sinusoidal signal. Phasor diagram
Okay,
is this. Sorry, I go to mouse. Phasor diagram is this. This. Okay. So phasor and vector is one and the same. Phasor diagram is equal to vector diagram. Vector diagram. Okay. All right then. Thank you so much. We'll meet tomorrow.